Hello, Hornets, and welcome. Thank you for joining me today. We're going to be taking a look at how do we graph systems that have logarithms and exponential equations and finding points of intersection between them. So we'll be using our calculator, and I am using my TI-84 CE Plus, and hopefully you have something comparable. And we're going to be taking a look at the natural log of e to the 4x minus 1 and 2x plus 5. Now, please be aware, when you see these things, all you're looking at is 4x minus 1 and 2x plus 5. And that's because there's that rule that says that the natural log of e to the x is x. So just be aware. Sometimes they're going to try to hide things from you, and you have to recognize what it is you're working with. So the whole idea is to put the two equations into our calculator, just exactly as I'm about to show you now. So I have my 4x minus 1, and I have my 2x plus 5. Now, for those of you who prefer, I'm going to go ahead and put it in purple. Natural log of e, let's try that again, of e to the power of 4x minus 1. Now, when I graph these, what you're going to notice is that the blue line gets covered over by this magenta line. All right, we're going to do a zoom 6 and see what happens. See how that magenta line just covered the blue line? Now the intersection is just out of our reach. So I'm going to have to change my windows so that my y's are just a little bit larger. Now I can see the point of intersection, and you can see that magenta line covering it again, so we do know they are equivalent. And I'm going to go second trace, find my intersection 5, between my first and second lines. And the intersection is at 3:11. Okay, so our point of intersection is located at x equals 3, and the value is 11. Please remember that we do not want to give a point of intersection. We want to state where it is and what the value is. So the intersection is located at 3, and the value of the intersection is 11. Let's go ahead and take a look at another one this time. We'll take a look at one that's a little bit more complicated. Natural log of 2x minus 1 and 2 to the power of 3x minus 7. We're going to put these both into our graphing calculator, just like we did before. So I have ln of 2x minus 1, and I have 2 to the power of 3x minus 7. Now, whenever we're graphing these, we know that logarithm is going to have an asymptote, and we know that it's moving toward the right. So it's going toward negative infinity as we approach that 1/2, and so we know we're going to have an intersection because of that going down. Let's go ahead and hit zoom 6, see what we get. And what I want you to notice is that there are two intersections here. Let me zoom in a little bit. See how there are two intersections? We have to find both of them. Second trace, find the first intersection, 5. You want to get over to the right. There it is. Enter, enter, enter. And the first value is 1.0347. We're now going to do it again. Second trace, find the intersection 5. We're going to move over to it and hit enter, enter, enter. And the second intersection is 2.4883. Now we have to expect that there's going to be at least one, but often there are two. Let's go ahead and take a look at another example. y equals, and this time let's do the natural log of x plus 7, and we'll do 3 to the power of 4x plus 1. Now remember, this has an asymptote and curves upward. This one has concavity up as opposed to concavity down, and we expect 2 intersections. Here we go. Starting with the natural log of x plus 7, then going to 3 to the power of 4x plus 1. Zoom 6. Notice there's our first intersection right there. There is our second intersection. Once again, the two equations, natural log x plus 7, 3 to the power of 4x plus 1, followed by a zoom 6. And we can see both intersections, one here and one here. Second trace, find the first intersection, 5. Now remember, we have to get closest to it. We'll always go to the closer intersection. We're right in the middle. It's a flip of a coin. So we can now see that our intersection is approximately 0 for the y value and -6 for the x. So the intersection is located at -6 and the value is 0. Second trace, intersection again. Once again, we have to get closer to it. We'll always go to the closer of the two intersections. And we have -0.1001, and the value is 1.9314. And this is just finding intersections between a system of two logarithmic and exponential growth functions. Alrighty. I hope this has helped you. I hope you enjoyed it, and that makes you feel more comfortable graphing. If you have questions, please make sure that you come in and ask. And if you liked what I've done, please remember to click like, and hopefully you have subscribed. Thank you very much. Please take care, Hornets, and we'll be going over this tomorrow in class. Have a great day. Take care and be safe. Bye-bye now.